Hello students, now today is our lecture 6 of problem solving classes of the topic vectors. So in this class we are going to solve the question based on the dot product and cross product. So now starting with the first questions, here the question says that prove that the A dot B is same as the B dot A. Now we are going to apply the definition of A dot B. So now A dot B vector, A vector dot B vector is equal to product of the magnitudes of the vectors A vectors, then B vectors, and cosine of the angle theta between them. If you are taking B vector dot A vector, so it will be what? It will be B vector, then modulus of A vector and cosine of the angle between them. So you know that both are same, so we can say that A dot B is same as B dot A. A dot B is same as B dot A. Now coming to the second questions, solution of second questions. Prove that projection of the vector A on the vector B is A vector dot B cap, where B cap is the unit vector along the vector capital B. So first of all, here we consider one vector, that is A vector. Now this is the initial of the vector A, this is the terminal point of the vector B, of the vector A. Now here we consider another vector, this one, this is our vector B vector. Now we are going to take the projection. We are going to take the projection of the vector A on the vector B. We are going to take the projection of the vector A on the vector B. So how can we do that? For this purpose, we are going to draw the two perpendicular plane which passes through the initial as well as terminal point of the vector A. So from here we are drawing the perpendicular. Now this perpendicular, the foot of the perpendicular is G and H, and this point I am calling initial point E and the terminal point is F. So now GH, if I am taking GH, this length is equal to projection of vector A on B vector. But this length GH is same as if I draw one more perpendicular from E on FH, and if I call this one is EI, so which is same as the length of EI vector. Now EI I can write as, if I consider this angle is theta, that means angle between A vector and B vector is theta, then this I can write as hypotenuse into cos theta. So base is equal to hypotenuse into cos theta. So these things I can replace as A vector, then modulus of B cap vector and cosine of theta, where I consider B cap is the unit vector along the vector B, along the vector B vector, which is same as dot product of A vector and B cap. So this is the formula by which we can calculate the projection of one vector on the other vectors. So in this case you have to take the dot product of the first vector and the unit vector on which we are going to take the projections. Now here with the help of the projections we can prove that A vector dot B plus C vector is equal to A dot B vector and A dot C vector. So first of all I consider this vector is our B vector. This vector I consider as B vector, and this vector I consider as C vector. By the addition law of the triangle we get this one, which is B plus C vector. this vector I called something, you can say some another vector, if you want you can write, but no issue. Now I am going to take the projection of b plus c vector on the vector A. On this vector A I am going to take the projection. That means through the initial and the terminal point of the vector we have to draw the perpendicular. From this point and from this point we have to draw the two planes which will be perpendicular the A vector. So now these I call GH, these I am calling as E and F. So now I am going to take the projection of B plus C vector on GH, that means on A vector. So here I am taking projection of B vector plus C vector on A vector, which is nothing but by using the previous formula B vector plus C vector, and then we have to take A cap, where A cap is the unit vector along A vector Now we consider in this way that if you take the projection of the B vector, so it will be GK. So now I am taking GK, this will be the projection of B vector on A vector. So this can be written as B vector then dot with A vector, unit vector. Now I am going to take projection of C vector on A vector, that is KH, which is equal to the C vector dot A cap. So now this length GH I can write as, this length GH I can write as GK length and plus KH length. That means total projection I can write as sum of the projections. Here this thing can be written as B vector plus C vector then with dot A vector, which is same as B vector dot A cap plus C vector dot A cap. If I remove the A cap by A vector, it will be what? We know that A vector is nothing but magnitude of the vector A and multiply with A cap. So if I multiply both the side by mod of A vector, if I multiply then it will be what? B vector plus C vector then product of mod of A with A cap, which is nothing but A vector, which is same as B vector dot A vector plus C vector dot A vector. Since we know that dot product is commutative, we can take the A dot B plus C, which is same as, you can write A dot B plus A dot C. So with the help of the projection we can very easily prove these beautiful results. Hope all of you enjoy this way of proving the results. Now coming to the fourth questions. This question says that one vector is defined, then what is its modulus? Its modulus will be A vector dot A vector, or you can say that A1 square plus A2 square and plus A3 square. So how can we prove this result? So here I am going to apply the first by the definitions. What will happen? A vector dot A vector. So by the definition it is product of the magnitudes of the vector and cosine of the angle between them. That means mod of A and cos 0 is 1. So what we have? Mod of A whole square. Again, if I define this A vector dot A vector by the properties, it will be A1I plus A2J plus A3K. Now this vector we have to take dot with again same vector A1A, A2J and A3K. So if we multiply component wise, we are getting a1 square plus a2 square plus a3 square. If you notice that the equation 2 and equation 1 has the same left hand side, so we can say that mod of a square is nothing but a vector dot a vector, which is equal to a1 square plus a2 square plus a3 square. Now this we can write as a vector is square root of positive square root of a dot a, which is same as positive square root of a1 square plus a2 square plus a3 square. So hope all of you understand this beautiful concept. It is very fundamental. We should write one quantity one time using the definition, and either other time we are using the property and we are calculating the dot product of two vectors. Now here we are going to find the angle between the two vectors. So angle between the two vectors, we generally use the dot product, and we define the dot product of two vectors in two different way. First we are taking the definitions a dot b vector, which is equal to magnitude of a product with magnitude of b, then cosine of the angle between them, that is the theta. So now we know that how to calculate mod of a, which is equal to 2 square plus 2 square plus minus 1 square, and this will be the square root sign. Again, mod of b we know how to calculate 6 square plus minus 3 square plus 2 square. Then we have cosine of angle theta between the vectors. So it is nothing but 3. This one is 7. Then you have cos theta. So now this is the one way in which we are able to calculate the a dot b. Now we are going to calculate the same a dot b by using their property. First we write component wise multiplication. 2 multiply 6, 2 times of multiply 3, then minus 1 times of 2. So it will be 12, then 6 minus 2. So what we have 4. Both are representing a dot b. So therefore 21 cos theta, which is equal to 4. Cos theta is equal to 4 by 21. So from here we are getting theta is approximately 79 degree. Hope all of you understand how to calculate the angle between the two vectors. We try to write the dot product of the vectors in the two different ways. One by using the properties, another by using the definitions, and we compare them and we calculate the angle between them. Now show that these vectors form a right angle triangle. This is a beautiful question. Here first of all we try to solve them whether they are forming a triangle or not. To show that three vectors form a triangle, you have to show the sum of the two vector is the another vector, or you have to show that their resultant is 0. So now here I notice that if I add b vector and c vector, then I am really obtained the a vector. So since I am getting a vector as the sum of b vector and plus c vector, so I can say that they form a triangle. So this vector they form a triangle. They form a triangle. Now you have to show that this triangle is a right angle triangle. So now we draw the diagram. This is our b vector. This is our c vector, and this is my a plus b plus c vector. This b plus c vector is same as the a vector. Now we are going to calculate the angle between the vector. So first of all a dot b. Now a dot b component wise we multiply a and b. So here we notice that 3 times of 1, then we have minus 2 times of minus 3, then we have 1 times of 5. So it is 3, then 6, then 5. Now it is 14, not equal to 0. So we can't say a vector and b vector are perpendicular. Now take a vector product with c vector. So what we observe, a vector 3 and c vector is 2, then a vector is minus component 2, its component is 1, k component is 1, or here k component is minus 4. So it is 6, then minus 2, then minus 4. So result is 0. So since the dot product of two vector is 0, and both the vectors is non-zero, so we can say that the vectors are perpendicular. So now since A vector is perpendicular to C vector, we notice that these angles should be the 90-degree. So now it is clearly that it is a right angle triangle. Going for the next question. Find the angle which the vector makes with the coordinate axis. So I advise to my students that for this type of question, you first draw one box. Try to draw one box and along the x-axis, y-axis, z-axis, taking the unit vector I cap, j cap and k cap respectively. Okay now, so this is our shoe box, this one. Okay, so now dear student, here we have this one. This is my x-axis, this one is y-axis and this one is z-axis. This is 0. So along the x-axis I am taking the unit vector I cap. Along the y-axis I am taking the unit vector j cap. Along the z-axis I am taking the unit vector k cap. Now I am going to calculate the angle between the I cap and the given vector. So I am taking a vector dot I cap, and suppose my vector is this one, and suppose that this is my vector OP. This vector I denote by A. Okay now, this vector is a vector. Suppose OP makes alpha angle with x-axis, beta angle with y-axis and gamma angle with z-axis. Gamma angle with z-axis. So now A dot I, when I am taking, so I have to multiply A vector by I cap. So here we are getting 3, and by the definition mod of A, then mod of I, and it will be cos of angle between them, that is alpha, which is equal to 3. So I cap is 1, mod of A is 3 square plus minus 6 square, that is 36, plus 2 square is 4. So now it is 49, that means 7. 7 cos alpha is equal to 3. So from here we get cos alpha, which is equal to 3 by 7. So now we are going to calculate alpha, which is equal to cos inverse of 3 by 7. Similarly, I am going to calculate the beta angle. Take the dot product of A vector with j cap. So now we are getting 6, and here we have 7 into cos beta, which is equal to minus 6. Then cos beta is equal to minus 6 by 7. Beta is equal to cos inverse minus 6 by 7. Now what about the third angle? Taking a vector with k cap, our answer is 2. Here I have 7 cos gamma, which is equal to 2. Therefore cos gamma, which is equal to 2 by 7. So now gamma is equal to cos inverse 2 by 7. Now going for the next question. Question number 8. Here we are going to calculate the projection of one vector on the vector B. So first of all we calculate the B cap, which is the unit vector along the direction of the B vector. So it will be B vector then divided by mod of B vector. So now it will be 4i then 4j plus 7k, and in the denominator we have 4 square is 16, then 4 square is 16, then 7 square is 49. Now we have 4i minus 4j plus 7k, and here we have root over of 32, 49, 81, that means 9 only. So therefore projection of a vector on B vector is equal to A dot B cap. A vector is I 2j plus k, and B cap is 4i 4j 7k divided by 9. So it will be 1 into 4 plus minus 2 into minus 4 plus 1 into 7 dividing by 9. 4 plus 8 plus 7 divided by 9. It is 19 by 9. So projection of the vector A on the vector B is 19 by 9. Prove the law of cosine for planes of triangle. Prove the law of cosines for the planes of triangle. So cosine's law we can very easily prove with the help of dot product. Suppose I am taking one triangle. So this is my one vector, that is B vector, and here I am taking this is C vector. Now this vector, that is the resultant, I am calling A vector. So A vector I can write as B vector plus C vector. So from here I am calculating C vector as A vector minus B vector. So now from both sides I am taking dot product C dot C, which is equal to A vector minus B vector. Then again value of C vector is A vector minus B vector. So here we can multiply in this way A vector dot with A vector minus B vector dot with A vector minus B vector. So here A vector dot A vector, which is mod of A square, A vector dot B vector, A vector dot B vector. Here we have B vector dot A vector, which is same as A vector dot B vector, because dot product is commutative. Now plus mod of B whole square. This we can write as mod of A square plus mod of B square and minus 2 A vector dot B vector. On the left hand side we have mod of C whole square. So now these things we can write as mod of C square which is equal to mod of A square plus mod of B square and minus 2 times of mod of A dot mod of B into cos theta. So now we notice that 2 times of mod of A mod of B cos theta, which is equal to mod of A vector plus magnitude of B vector minus magnitude of C vector, magnitude of square of the C vector. So from here we can calculate cosine of angle theta is mod of A square plus mod of B square minus mod of C square divided by 2 times of mod of A dot mod of B. So hope all of you understand this concept, and this is beautiful questions. One of the interesting questions and beautiful questions. So this is known as the cosine law, and this law we can very easily prove with the help of this dot product. Hope all of you enjoy these dot product rules to calculate cosine formula. Now going for the one more interesting questions. Prove that diagonals of a rhombus are perpendicular. So now first of all we draw one rhombus. One rhombus we are going to draw. Suppose this side is denoted by the vector A and this side is denoted by the vector B. So you know that their resultant is the diagonal, this one. This will be the resultant vector. So now here we can say that if I call this point is OPQR, so now OQ vector is nothing but A vector plus B vector. Now take this diagonal, RP diagonal. So RP vector we can write as A vector minus B vector. As if you have any doubt, you can write in this way: B vector plus RP vector is equal to A vector by the triangle law. From here you can calculate RP. Now take the dot product of these two diagonals vector. What we have, OQ vector dot with RP vector is equal to A vector plus B vector and dot with A vector minus B vector. So now we have A vector with dot A minus B vector and plus B vector dot with A minus B vector. So A vector dot A vector, it will be mod of A square minus A vector dot B vector plus B vector dot A vector minus mod of B vector its square. As we know that dot product is commutative, so A dot B and B dot A will be the same value. So what we ultimately have, A vector square then square of the modulus of B vector. What we know that since it is a rhombus, all the sides having the same length, that means magnitude of the vectors is same. Magnitude of the A vector is same as the magnitude of the B vector. So here we can write magnitude of A vector, but we replace magnitude of B by magnitude of A because both are same. So these two cancel out. So now what we have, the product of diagonals, dot product of the diagonals vector is 0 and both the vectors are non-zero. So product of the diagonals vectors are 0 but both are non-zero. So it is only happened if OQ vector is perpendicular to RP vector. That means this angle is 90 degree, as OQ vector is not equal to the 0 vector and RP vector is also not equal to 0 vector. Now this is one of the beautiful application of the dot product, where we very easily show the diagonals of rhombus are perpendicular. Now here find the unit vector perpendicular to both the plane. So a plane containing the vectors A and B. Okay now. So now we have this one is our A vector and one is the B vector. So suppose this I am taking A, this I am taking the B vector. Now I am taking the cross product of A and B. So if I am taking the cross product of A vector with B vector, so this will be nothing but determinant of first row have I cap, j cap and k cap unit vector. Then we have 2, minus 6, minus 3, B vectors component 4, 3 and minus 1. So now when we are taking the cross product of two vectors, so I am getting this will be the cross product. This will be the cross product of the vectors A and B, and the direction of the vector is perpendicular to the plane containing both the vectors. This will be the vector A cross B. Okay now. So now we are going to calculate this determinant. So minus 6 plus 9. Here we have minus 6 plus 9, that means 3. 3 I cap. Here we have 3 I cap. Next, 3 I cap. Next we take j. So it will be minus 2 into minus 1, that means minus 2, and 3 into 4, that is 12 plus 12. So here we have minus 10 j, and for the k cap we have 3 into 2 6 and plus 4 into 6 24, that means 30 k cap. 30 k cap. So let me check the calculations one more. So here we have 6, minus plus 6, it will be the 15, sorry, it will be 15. So 15i minus 10j plus 30k. From here you have to calculate the unit vector. Suppose I am calling the unit vector is u cap, which is equal to a vector cross b vector and then divided by its magnitude, a vector cross b vector. So what we have, 15i minus 10j plus 30k, and its magnitude will be 15 square 225, then 10 square 100, then 30 square 900, 12 25, so it will be 3 into 4 3 and 5, it will be 35 only. So now what we have, if you take 5 common, so it will be 3i 2j 6k divided by 7. So this will be the unit vector. So now we are just they are just saying calculate the unit vector. So this unit vector may be on the upward direction or maybe on the downward direction, both are possible. So you can take plus and minus sign. Okay, now we are taking plus and minus sign. Okay. Now we are going for the next question. Find the work done in moving an object along the vector r if the applied force is this. Force is given and displacement is also given. So now suppose this is the force vector F and this is our displacement vector r. So now if you are going to calculate the work done, you have to take the projection of this vector on the r vector. So now I am going to take the projection of the vector F on the vector r. I am going to take the projections of the vector F on the vector r. So this is my F vector, that is the force, and this is the displacement. So you know the definition of work done. Work done is equal to magnitude of the force, magnitude of the force in the direction of motion, into distance moved. So magnitude of the force in the direction of motion is nothing but mod of F cos theta, this component, mod of F cos theta. Now into distance move mod of r. So mod of A into mod of B into cos theta, which is nothing but F dot r, which is equal to, if you take the component wise multiplications, 3 dot r 3 multiplied 2 plus 2 multiplied minus 1 plus minus 5 multiplied minus 1. So it is 6 minus 2 plus 5. So this will be the 9 unit. So displacement of the vector along the direction r is 9 unit. Hope all of you understand this concept. Coming to the one more beautiful questions, that is question number 13. Now solution 13 part 1, what they are asking, find the equation of the plane perpendicular to the vector these and passing through the terminal point of the vector b. So passing through the terminal point of the vector b. Okay now, so this plane, find the equation of the plane perpendicular to the vector. Your plane is perpendicular to this vector. So suppose this is the plane and this plane is perpendicular to this vector A, and the plane is passing through the terminal point. Suppose this is the terminal point Q of the vector B, and B is starting from suppose somewhere here. Okay, so this is the this point. From here the b vector starting and ending is here. Okay, now to terminal point b. So now what I am taking, the initial point I am taking as the origin. So this will be the position vector. So q has the position vector b vector. So q has the position vector as the b vector. Okay, now so on the plane I am going to take one arbitrary points, that is p points, whose coordinate is x comma y comma z. Or from the origin, if you joint, you are getting the vector, position vector of the point p. This vector I am calling as r. Now joining p and q, so you are getting one more vector. So pq vector is nothing but q vector minus r vector. Q vector minus position vector of q minus position vector of p. Okay, the position vector of q minus position vector of p, not the qp, position vector. So position vector of q, you see that it is the b vector, and position vector of p is nothing but r vector. Okay, now this vector lies on the plane, and you notice that a is perpendicular to this plane. So that means this vector a is also perpendicular to pq. So a vector is perpendicular to the pq vector. So this will imply their dot product should be 0. So now a vector and pq vector we are taking. So now b vector minus r vector multiply with a vector, this will be 0. So what we have, a vector dot r vector is nothing but a vector dot b vector. Okay, now so this is the equation of the plane. This is the equation of the plane. So a vector dot r vector dot a vector is equal to a vector dot b vector. Okay, now so this is the equation of the plane. Now they are asking, can we find the distance of this point from the origin, also find the distance of the origin from this plane. So now we are going to calculate the perpendicular distance of the origin from this plane we are going to calculate. So now what we do here, if you are taking the projections of OQ vector, if you are taking the projection of OQ vector on the vector A, if you are taking the projection of OQ vector, that means the B vector on A vector, because this is the perpendicular, then you are going to get the perpendicular distance of the origin from the plane. So perpendicular distance of origin is equal to projection of B vector on A vector. So which is nothing but you have to take b vector dot a cap. B vector, you know that it is given I plus 5j plus 3k, and the a cap vector you have to calculate a cap. A cap vector is also you can easily calculate, which is equal to 2i plus 3j and 6k divided by its modulus 4 plus 9 plus 36, that means 7. So after calculations you are getting 35 by 7, that means 5 only. So in this way you can calculate the perpendicular distance of the origin from the plane. Now this is the last question of this lectures. So here we are going to calculate the proof that any vector A can be written in this form. So first of all we consider, let A vector is defined as a1 I cap plus a2 j cap plus a3 k cap. Now A vector dot I, which is equal to a1. If I am taking a vector dot j, I am getting the component a2 only. Remaining component becomes 0. A vector dot k cap, I am only getting a3. So now in the equation 1 I am going to replace this value. So a vector I can write as a vector is a cap, a vector dot I cap, then I vector. Their dot product a dot I cap multiply with I vector. A vector dot j vector j cap multiply with j vector. A vector dot k cap multiply with k cap vector. So in this way we are expressed any vector in this way. This is one of the important results which is very important for the exam purpose. Now in the next lecture, in the lecture 7, we are going to discuss the vector and the scalar triple product, and we are going to solve few questions on that topic in the next lecture, that is the lecture number 8. Hope all of you enjoy these Maths Academy's videos. I request you to spread the Maths Academy's link to all of your friends, in your groups, in your colleagues and your closer friends, your relatives, so that maximum persons uh, can be benefited with these videos and the things that I am describing on the YouTube or in my website mathsacademy.org.in, where everything is free. You can download any video, any content absolutely free. Now in that video also, in this site also, I'm going to upload some mathematics books which are very helpful for the Olympiad purpose. Till then, bye, have a nice day.